Hello, hello. Am I audible? Anirban sir, please check the mic.
Yes, ma'am, you are audible.
Okay, thank you. Anil sir, are you there? Can you just share the open? I mean, your video is not showing, so can you just share your video? I mean, your camera is not on. I think you can start the video.
Yeah, can you hear me?
Yeah, you are audible, sir.
You want me to share the screen?
Sir, you can just start video is there. You can just open your camera so that we can see you on screen.
Yeah, I started the video, no?
Okay, okay. Now it's coming. Fine, sir.
Yeah.
So I think we are just waiting for a few more participants to join. Exactly 11 o'clock, we are going to start.
Sure, sure.
Okay, thank you. Okay, shall we start? Everyone is ready, I guess. A very good morning to all the participants present here in this 5 days National FDP on Artificial Intelligence, Machine Learning and its application. The 2 days went well. We had a very eminent speakers from IITs and IIITs. In today's sessions, we are having Dr. Anil Rupala sir from IIIT Hyderabad. Sir is Associate Professor in the Department of ECE, IIIT. I would now like to request Dr. Anirban Ganguly sir to read the profile of Dr. Anil Rupala sir. And once again, sir, welcome you in BIT in the online session. Over to you, Anirban sir.
Thank you, Dr. Papia, ma'am. So again, on behalf of BIT, I again welcome you, sir. Dr. Anil Bhupala is presently working as Associate Professor at IIIT Hyderabad. He has joined IIIT Hyderabad in July 2019. Dr. Bhupala has received his BTech in Electronics and Communication Engineering from JNTU Hyderabad in 2005 and MTech in Electronics and Communication Engineering from NIT Kurukshetra in 2007. And he has received his PhD in Signal Processing from IIT Kharagpur in 2012. From 2012 to June 2019, he worked as Assistant Professor at IIIT Hyderabad. He has published over 100 articles in reputed publication. He is currently handling 2 sponsored projects and completed 700 projects. He is guiding 5 full-time PhD students and 9 MS students. He successfully guided 5 PhD students and 7 MS students. He has given more than 75 invited talks in various workshops and conferences. Today's topic of discussion will be on AI and ML in speech processing application. So now I would like to give it to Dr. Bhupala, sir. So you can start the session.
Yeah, thank you. Thank you for the organizers for inviting me. Hope my voice is clear.
Yes, sir,
Yes,
your
sir.
voice is clear.
Okay. So can you see my screen?
Yes, sir, it is visible.
Yes, sir.
Yeah. 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 In today's talk, I will try to give how AI is applied in speech processing. Initially, I will discuss about what is the purpose of this speech processing, and then I will tell what is the significant changes happened over the years in the field of speech because of AI. And then I will also throw some thoughts on thoughts on what can be done in future, and also what we are working in our lab actually. So by the way, we don't have any departments in the IIIT. I contribute to EC and CSE both, but we have all research centers which are focused on areas. I belong to Language Technology Research Center, where we focus on speech, NLP, etc. So we have faculty mix of both computer science and EC. Okay. So moving on. So this is how typically our speech signal look like. This is how typically speech signal look like, and so people will confuse between speech, voice, and audio. They are different actually. They are not synonyms. Audio means speech plus music. Okay, so I'm not talking about audio processing. I'm talking only about speech processing. So once somebody speaks, let us say I say I'm from IIIT Hyderabad. Okay. If I say one sentence, your mind is getting a lot of information. Your mind is getting a message, what is my institute name or something, some information you are getting. And you also get what language I'm using, what gender I am in, what may be my age group, what if you know already my voice, yes, Anil is speaking, you can understand, and what emotion I'm speaking, whether I'm speaking normally or angrily or happily. If somebody has some speech disabilities, whether they're able to speak properly or not. All that information your human brain, does it automatically. So what we want is this to be done by machine, because we want it to be done by machine, because that is the motivation for speech processing, is the make human machine interaction. You can see here human machine interaction as natural as possible. Human machine interaction as natural as possible. Okay, so because speech is our natural mode of communication. So whenever you want to convey some information to your friend or your family member, you use the speech as a modality. But if you want to interact with the machine, right now you are using either keyboard or touch screen, etc. majorly. So that is a bottleneck, because the people who has the people who has the who has the education background only can operate the systems properly. For example, you give iPhone to your grandparents who are not well educated, for example, even maybe your parents as well, which are not well educated, they can't operate it efficiently, other than picking the call and closing the call. They hardly find, sometimes they don't even know how to save the contacts or how to operate the mobile properly. Same with the system. So if you, on the other hand, you might heard about these terms, right? Apple Siri, Alexa in Amazon Alexa, or Microsoft Cortana, or OK Google. These are all current speech technologies which enable you to understand your speech, and your devices can give the required information or the action what you tell. You can you might have seen Alexa, right? Alexa, you may say, Alexa, play so and so song for me, or OK Google, hey Google, you play so and so song, or hey Google, what is the weather in Hyderabad? Hey Google, like that. You can give the voice commands and then action will be done. This is comfort for everyone, but on the other hand, let us say farmer want to know the information, so you don't know how to operate the mobile or system, but he can say, hey Siri, or Siri, ask them information, or ask the commodity price, or you can get the information, because The beauty is that a lot of information is there in the internet, but it is not going to the needy actually. So because information is there in the form of text, but many people in India, more than 60% of the population don't know how to read and write. They may know how to speak, but they don't know how to read and write. Even their mother tongue, they don't know how to read and write. So there is a lot of need for these speech technologies, one for the comfort for the educated people, and also for the need for the uneducated people. Okay, those means those people who don't have reading and writing capabilities. I think I no need to give more motivation or explanation for this speech processing, because knowingly or unknowingly you're already using a lot of speech application. One such is the Hey Google or Alexa, etc., and also text to speech in the form of Google Maps, etc. I will touch upon that. So before moving on, speech is a very typical signal. Unlike image or text or biomedical signals, speech is a particular signal which has the production mechanism, which makes signal more, a natural signal actually. For example, text. So if you type, I type, or you type, anybody type, the text will be, a text will be same. But you speak the same sentence. For example, I am from Hyderabad. You ask some 4 of your friends to speak the same sentence, I am from Hyderabad, and try to record and see, and try to show these 4 signals to the 5th person, say that, whether these 4 are same or not. They will say they are not same. Okay, but if you play them, the information is same. I am from Hyderabad only. But if you see the signal, if you record and see the signal like this, right? Everybody's signal is different, because everybody's pitch is different, everybody's speaking style is different, everybody emphasis of the energy is different. So which makes the signal more complex actually, or in other words, speech on a lighter note, speech is like cursive writing. You might have seen the doctor's writing, right? Only that corresponding medical shop person only will understand, right? Because it has its own signature. Similarly, speech is, even the information is same, the speech will have their own signature. Everybody's signature will be there on speech. Everybody's speech is different. Okay, so which makes the problem more complex. Because if, for example, I'm building Alexa or speech recognition like Siri, so it has to understand anybody's speech. Whoever says, let us say I'm from Hyderabad, let us say 10 different people say, still that Alexa has to recognize them as the same information. So which is a complex problem. So which our model training should take care of that. Okay, and this is the speech production mechanism. Anyway, these 3 happens in the brain: message formulation, language coding, and neuromuscular commands. But the main speech production is this one: vocal tract system and excitation source and speech. So due to shortage of time, I'm not going to a lot of details, but in your digital signal processing course, if you are teaching LTI system, of course we have to teach LTI systems, linear time invariant systems. You can model vocal tract system in a given short duration of speech. We can model vocal tract system as a LTI system. Actually, it is a time variant system, but given a short duration of speech, we can assume vocal tract system as LTI system. So we study a lot on LTI system, but if somebody asks a practical example of it, you can say that, you can model vocal tract system using LTI system. Similarly, excitation source can be modeled using impulses. So usually in digital signal processing course, we use a lot of emphasis on impulse. And LTI system, one of the practical examples for that is a speech production mechanism. Okay, so basically, if you see this figure, the components of speech production, what happens is that the lungs will give you the required energy in the form of air that passes through something called vocal folds here. Vocal folds here, that the rate of vocal fold vibration is nothing but your pitch. You might have heard the word pitch, right? So the pitch is nothing but here you have vocal folds, they open and close. Okay, the rate of vocal fold vibration is called pitch. So your air passes through these vocal folds, and this vocal tract system acts as a resonator, and depending on the position, different frequencies. The sounds will come, different sounds will come actually. Okay, so lungs, larynx, and this vocal tract system acts as a speech production mechanism actually. Okay, so everybody's speech is unique. Okay, because everybody's vocal tract system is different. Everybody's these vocal folds are different. You might have know, right? So children pitch is more than female pitch, and female pitch is more than male pitch actually. So the rate of vocal fold vibration is different for different people. Okay, so yeah, as I said, speech production, a lot of material is there in the internet. If you want to give a practical example of LT and excitation, you can make use of this. So actually, there are two set of researchers in speech processing. So one set of researcher is that, like, anyway, speech is like any signal, like image or a biomedical or any signal, and try to take it and do some processing and give it to the model. That is the one way of doing. But there are some set of researchers. Speech is a different signal because which has a production mechanism. There is no production mechanism for image or some signals, but there is a production mechanism for speech. Anything you make sound is not speech. Speech is the one which has the meaning and also which follows some production mechanism. Okay, so exploit the production mechanism and build the system is another aspect of speech processing. And also, more importantly, for traditional systems like speech recognition, etc., which I will touch upon slowly, you can build any other way. But if you are working on speech pathology or speech production, a lot of work is happening. In that, we should have a clear idea on speech production mechanism, how different sounds are coming, what are the different sounds, what is the difference between vowel and consonant, right? And what is the difference between different consonants, why different consonants are coming out of our mouth, what is happening actually, that mechanism we should know. Okay, because it's a AI focused workshop. I am not going to the details of more details of speech production, but that is a very interesting topic. Okay, coming back of a brief overview of speech production. So once somebody, as I said, once somebody speaks, right, all this information of message, language, gender, all this is there in the signal, and your human brain gets that automatically. But now what we want is, we want machine to do that. Right? So if machine takes the speech and convert into text or message, that is called automatic speech recognition. It is one of the very important system, is the automatic speech recognition, which every one of you might have used in your in your day-to-day life, because voice-based searching is now very common. Or Alexa or Siri, any of these things are now smart cars, smart monitors, smart TVs. Everywhere you are using speech as a input. Okay, then that first block is the automatic speech recognition. So that is speech to text conversion. The other opposite system is text to speech, because let us say you are asking, hey Alexa, what is the weather in Hyderabad? Then Alexa has to respond for you, right? Alexa says, yeah, weather in Hyderabad is 25 degrees. So that is called text to speech. Okay, TTS, text to speech system, which all of us are using in Google Maps, etc. Right? For example, I want to travel from AAA to BIT. So I don't know the road, for example, then I will put the Google map and start driving. It will say for you, go straight for 1 kilometer, turn left, turn right. All that information is there on the maps, and for easy, it will help you to navigate actually, because you are driving. So it will help you. Text to speech system will help you to give the instructions. Okay. Similarly, we are having spoken dialogue system, and similarly we have speaker recognition, because everybody's speech is different. Okay, God has gifted everybody unique voice, so we can also use speech for the biometric purpose. So speaker recognition is one such task we can do from speech. And similarly, we can also express emotion through speech. Emotions need not be only through speech, because we can use facial expressions or actions or language. Many ways emotion will be expressed, but speech is also one of the important modality to express the emotion. So can we recognize the emotion from speech? That is emotion recognition system. Similarly, language identification. So identifying a language from the speech. So For example, if you call to call center, right, it will ask press 1 for Telugu, press 2 for English, blah, blah. So why we have to press 1, 2? If I'm speaking, you should understand my language, right? That's why none of our parents or grandparents will call to call center, because it will ask to press 1, 2, 3, that they don't know how to do that. It looks simple for you, but it is not an easy thing for others, actually. Okay. So, but on the other hand, you speak, call to some toll-free number, you start speaking, and if system is backend system is understanding your speech, that will be more user-friendly, actually. Okay. Similarly, we can also develop a pronunciation tools, evaluate for not only clinical purpose. I think even in TOEFL, etc., where system tests your speaking abilities, so they are using some kind of pronunciation evaluation tools, actually. And similarly, if somebody has problems like stuttering or dysarthria or autism, so these kind of speech problems are there, we can also develop a tools using AI to give a feedback for their pronunciation, etc. Similarly, we can also use AI as because speaker information is there in the speech, we can also use it for forensic investigations. If you have a suspected speech, so we can do some forensics on that. And similarly, speech coding is not AI-based system, but speech coding is the compact way of representing the speech. Okay. So these are the major systems of speech. Okay. ISR, TTS, speaker recognition, emotion, language, etc. Still some works are going on, but to be frank, these problems come to some saturation because a lot of work has happened already, and very good algorithms are already in place. But if you want to contribute in these traditional areas, you have to spend a lot of time and understanding, because many contributions are already done. To beat them is not easy. Okay. But anyway, good part is that, because research come to some stage, that's why the products have come out, right? TTS product has come, ASR product has come, speaker recognition also people are using as a biometric, etc. Still, we can do something in the emotion, LAD, etc. But these are a little bit typical problems to address because of the lot of advanced algorithms. Okay, having said that, still we can do a lot of work because in Indian context, we have to do a lot of, because India is a multilingual society and our languages are not rich resource language, because that means we don't have much digital content to build the systems. And similarly, a lot of work can be done in the clinical, in the speech pathology, okay, where a lot of problems of speech need to be understood. Okay. So another important problem nowadays people are working is speech-to-speech translation. So Indian government also prestigiously launched this program called Bhashini, which is actually aiming at speech-to-speech translation. For example, India is a multilingual society, right? So we have a language barrier. If I go to Kolkata, I will find difficulty to communicate in Bengali. Delhi, people may not know Hindi, South Indians may not know Hindi, etc. So language is a barrier. Vice versa, if they come to South, they also face the same problem. So can technology fill the gap? And also, not only this, a lot of content is there in the English. A lot of educational content is in the English. Can we convert them into Indian languages? Right now through Swayam, etc., government is trying to do manually, but it's a very time-taking process. So can we do it semi-automatically, not fully automatically, but semi-automatically? Human will be in the loop, but can we ease up? Can we ease up that process of converting English to Indian languages? Is the main target for this speech-to-speech translation project. The speech-to-speech translation is a big problem because converting, let's say I'm converting Telugu speech to Bengali, right? So first you have to understand Telugu speech and convert into text. The text need to be converted into Bengali text, and Bengali speech should come out. And not only that, I don't want Bengali, for example, take Man Ki Baat. I think all of you know what is Man Ki Baat, where Prime Minister speaks last Saturday about some or other aspects. So let us say he speaks in Telugu, he speaks in Hindi. I want to listen in Telugu, but I don't want somebody speak in Telugu. I want, let us say, Prime Minister Modi himself will, as if he is speaking in Telugu. Can I create that kind of speech? Is the target, actually. So it's a big problem. So a lot of work can be done in that space because ASR on machine translation and TTS. All modules are required, and all modules are interconnected now because it's not individual system. So any error will propagate. So how to handle those errors, etc., is a good interesting problem now, because because ASR, MT, and machine translation and TTS come to some stage individually. So if you combine them, what aspects they pose, and also it's a live lecture conversion. So in long run, the target is, can we do movie dubbing automation? Okay, remove the music. Let's say you have a talkie part of a movie. Can I take that and convert into the language what I want? Those are the next 5 to 10 years targets for this field using AI. Okay. So yeah, these are already some of them. You are already I already emphasizing on what is the importance of speech technologies, right? So better human machine interaction, smart appliances which you're already using like Alexa or smart TV or smart cars, etc. Okay. Similarly, we can also use it for personalized therapy, etc. Okay. Or getting the information about the education or health, etc. Also, we can use like Alexa for this kind of purpose: education, agriculture, healthcare. Very, very soon you'll get a product. You can give Alexa kind of product to your kid, and your kid can talk to Alexa and get the required information actually in the education domain or agriculture or healthcare domain, etc. So yeah. So this part is any typical AI system will have a couple of steps. Yeah, I can show that slide, I guess. Yeah, any typical machine learning model will have 2 modules. One is a feature extraction, and other is the classification or model building, and then use it for classifying actually. So basically, for example, there are 100+ people are there in this session. So I want to recognize all of you. So I should extract some features, no? I should not extract how many eyes you have or how many legs you have, etc., which is a redundant information. Mostly 99.5% of the people will have same information. So we don't want that. We want some features which will help you to classify you. Okay, maybe your name, or maybe some aspects of your thing. I'll extract as a feature and build the model actually. Similarly, we have to extract some features from speech or any other signal for that matter, extract the features and give it to the model actually. Okay, but because of deep learning, it's not true every case, because still we can use deep learning plus these features, especially in speech side. But many places like image processing, etc., this part is skipped actually, and you can directly give data to networks like CNN, etc. But in speech, still we'll use feature extraction plus deep learning, or people are now skipping this feature extraction and creating something called spectrogram. From speech, we can create a spectrogram, which is nothing but the output of short-term Fourier transform of a speech, right? So that they are giving it to the, again, neural network model actually. Okay, so that's how typically it goes. So this is one of the standard feature is called malfrequency capsular quotient. So basically, this is a speech signal which has a lot of redundancy, like your number of legs, ears, etc., which we don't want for model building, but we want something which is represents the vocal track or some aspect of this signal which is unique for it actually. So that that we can, right, earlier people used to use capsule features, but now the spectrogram which I mentioned here, right, it is nothing but take a speech signal and they chop it into small frames actually. So why small frames? We assume that within this frame my signal is stationary. Strictly speaking, speech is a non-stationary signal. It's obviously, right, it depends on what you speak. Every time you won't speak same thing, right? So it depends on what you speak, signal will come. So how it can be stationary? Obviously it is non-stationary. Non-stationary means the signal characteristics change with time. So the beauty of speech signal is it won't change rapidly actually. It has the stationary. So if you record it and see, speech signal and try to zoom it, within this short duration, the signal looks like a periodic signal actually. So that's why speech is called quasi-stationary signal. This frame is very small actually, only 20 milliseconds. 20 milliseconds, very small segment actually. So which corresponds to some 2 to 3 pitch cycles. Okay. Within that, we assume my signal is stationary and extract the Fourier transform and get the information. And if you attach all that information of short-term Fourier transform, that is nothing but spectrogram. The spectrogram is time versus frequency, and every frame you will get the frequency information. So that's why it is like an image actually. X-axis is it's a 3-dimensional. X-axis is the time, y-axis is the frequency, and other axis is the amplitude actually, frequency information, time versus frequency information. So spectrogram. So right now people are trying to use directly spectrogram. Before that, there is a after getting this Capstrom to highlight this vocal tract features, they are using some other they're using some other algorithm that is called Capstrom algorithm. Capstrom is nothing but, if you see first 4 letters, if you reverse, that is the spectral. Capstrom, if you reverse first 4 letters, that is spectral. So that is nothing but Capstrom is the inverse of spectrum actually, not inverse of simple spectrum. It is inverse of logarithm of spectrum, which actually gives a better feature actually. It's one of the standard feature actually. So this is the algorithm for that, take a frame of speech signal and then take Fourier transform. And then again, Mel filter bank is applied because your human ear follows the auditory system. Anyway, you want to replace human ear with the machine, right? Actually why these speech problems are so complex and why it is took a lot of time to come up with Alexa, etc., right? It is because, speech production is completely understand how speech is coming out, which I mentioned in the beginning of the talk, is completely understood how speech is coming out. But how human understand the speech, how your brain understand the speech is not known actually. If that is known, that could have been replicated, that we don't know. Actually, what we know, signal goes to your ear, right? Signal goes to your ear and it will be, given it to the neurons. After that, what happens, we don't know actually. So that's why, it is a different problem actually. Okay. So, yeah, coming back. So as typically speech systems, I'm talking about mainly traditional systems only. Okay, these traditional systems, which I mentioned already, speaker recognition, emotion, etc., can be grouped into 2 categories actually. Can be grouped into 2 categories. Speaker identification, language identification, or emotion recognition. These are all one set of problems. They are simply classification problems. They are simply classification problem. What it means, like text classification, image classification, or biomedical signal, any classification problem, if let's say some algorithm is working better, we can blindly apply it here also, because these are all simple classification problems. But on the other hand, if you see the below ones, automatic speech recognition and text to speech, they are not simple classification problems actually, because in speech recognition, you are going to speech to text domain. In text to speech, you are going to text to speech domain. So you are going from one domain to other domain. Okay, speech to text or text to speech. So they are not simple classification problems. They are sequence to sequence mapping problems. So the sequence of speech should be mapped to sequence of text, vice versa. So those are nothing but sequence to sequence mapping problems. So they are not simple classification problems. Here we need to capture the sequential information. That means we need some memory in the AI system. Okay. So that's why here some set of models are very famous. In that, one of the famous model is hidden Markov model actually. Hidden Markov model. So that is very famous in this kind of, even for machine translation or video analytics, wherever we want this kind of sequence to sequence mapping, hidden Markov models are very famous. Okay. But here hidden Markov model is not required. Simple Gaussian mixture models or support vector machines, these are famous actually. Gaussian mixture model is very famous in speech especially, right? The Gaussian mixture model has a history of maybe 15 to 20 years, and this hidden Markov model has history of more than 25 years, 20 years, 25 years. But suddenly, these are not new problems, but suddenly what happened? Neural networks has come, and for all these systems, now unfortunately or fortunately, 20-25 years of effort is in vain now, and it's all about neural networks. Okay, all the baselines for these systems is neural networks only. So now let us spend few minutes on why this neural network, what is this neural network, what is this AI boom actually. This workshop is happening because of AI boom, but it is not that AI is new actually. AI is there from long, 67. Some of the algorithms are as old as 70 years, 60 years, okay? It's not new thing, but why it got popularity now? Why it got, a buzz term now? It is because, anyway, before going to that, even my title has AI and ML. Actually, that is a wrong way of putting, because if you want to use one term, that AI is enough, because AI covers ML covers DL actually. So one term, if you want to use AI. ML is a part of AI which uses some set of algorithms, particular algorithms, statistical algorithms. Deep learning is another set of neural network algorithms, part of machine learning, right? So that's why, if you want to use one term, it is better to use AI only. Just AI in speech is good enough, or AI in any area is good enough, because which covers the machine learning and deep learning part. Okay, coming back, this diagram is the reason for this AI or BTech in AI or this kind of AI workshops, etc. Okay, as an advice, I also I'll try to tell you why this AI is getting a lot of popularity, whether you like it or not. I also not fond of AI. Okay, that's a different matter. But yeah, it's not a simple thing you can discard and do whatever you want actually, because it's a very impactful area. So what I suggest to all of you is that whether you are working in VLSI or embedded systems, or or communications, or any area you want to work, even if you are going anyway, software is all about AI now. So any area you are working, or you are a CSC guy or EC guy or a mechanical or civil engineer, whoever it is, okay, please understand, AI is nothing to do with computer science. AI is nothing to do with ECE, for that matter, any branch. That's why it has come as another branch, right? Now BTech in AI has come because AI is a mathematical model, it's nothing but is a statistical model. So anybody can learn, because everybody in their life, right, in their engineering course, or even in the life, they use the statistics, they use the data. So wherever you have a data, and if you want the inference or classification or some kind of statistics or heuristics from the data, you have to use the machine learning or AI. Okay, so that's why you see AI as a tool, just like you are learning C language, or why you are learning C language you are learning, it helps for the programming. Similarly, Python nowadays, or similar to that, you just try to learn machine learning as a tool, which will be very handy tool actually, whatever may be your domain, because civil engineers are applying AI because to predict the curve fitting, or to to analyze the building quality, etc. So much of machine learning is used in civil engineering, mechanical engineering, fault detection, etc. Even politicians are using to know their the chance of winning. Drug discovery requires AI. You assume, as long as the performance are coming good, this AI is getting a lot of prominence. Okay, that's why treat AI as a tool. So don't be illiterate in that. Try to have a hands-on AI experience. Okay, it's a advice to all of you. Okay, so don't say that I'm not an AI guy, but unfortunately AI is nothing to do with any area. AI is for everybody. Okay, so at the same time, domain knowledge, at the same area specific knowledge. Let us say you are working on VLSI, you can go deep into the VLSI, no issues, but AI also can help you sometimes to do something, maybe some prediction, or some layout prediction, etc. So why this AI? It is not the, even neural networks is not new. It's like 1950s. People will say it as a second wave now, but if you closely observe the history of neural networks, it's a kind of third wave. So initially 1950s is when neural networks have started inspired by human brain. And in 90s, there is a lot of buzz on that, and a lot of people have worked on that. And then slowly people thought, this has some issues, neural networks, etc. Then other machine learning people used, but now AI means machine learning. So AI means neural networks, because the reasons are following. You can see this figure. If you closely see this figure, right? So nowadays the amount of data, why this neural network become popular? If let us put the question in that way, why this neural network? Obviously, the reason for AI boom is neural networks. There is no doubt about that. Okay, then what is the beauty of neural networks or the other machine learning algorithms, right? So so there are some 3-4 advantages are there actually. Some non-critical advantages is that nowadays amount of data is more, because there is additional advantage of neural network that is nothing to do with neural networks actually, but added advantages. Actually, the amount of data is now enormously increased in any of the fields, most of the fields, and the computation power also increased. For example, you have huge data, but you don't have a computation power, you can't do, but you have GPUs, multi-core CPUs, etc., to handle the data. Those two are the added advantage. Actual advantage of neural networks are two actually. One, what is that? If the amount of data is more, obvious performance should be increased actually, but if you see this diagram closely, even if amount of data is low actually, if amount of data is low, this red line you can see that traditional algorithms are working better actually. But the moment it crosses particular amount of data, they are getting saturated. Okay. And this deep learning is keep on improving. For example, I am using Alexa or using Siri. Siri is also not new. Siri is there from 10-15 years, but it's not so popular actually in Apple, because 10 times if you speak and it is giving 4-5 times error, only 3-4 times or 5 times it will understand correctly. Then who will use? But on the other hand, let's see, if I'm using for 10 times, only one time I got error, 9 times it's working fine, right? Then people can develop a product out of it. That's how, why Alexa has come, right? Alexa, there's a small, interesting story actually. This Alexa, right, in Echo Dot, Alexa, Amazon Echo or something has come, I think 5 years back, 5 to 6 years, 5 years back, it getting popular. 2018-19, that time is where this product has come, Alexa or Echo, Amazon Echo, and speech-based assistants actually. So you might have heard the name Professor Raj Reddy. He is very popular in US in AI. He's 80 plus years. He's very prominent in Indian government also. From US, he will give a lot of suggestions. His IIIT started because of him, and other IIITs also started because he's a very influential guy. He's our chairman of IIIT, but anyway, he's stepping down because almost from 20-25 years, he's the chairman, so he's stepping down. But there is an interesting connection between this Alexa and this Professor Raj Reddy. What is that? Professor Raj Reddy is the first Stanford PhD in computer science. Basically, he's a civil engineer. Okay, he's a civil engineer. That time when Stanford is starting computer science program, then just like now AI program is started, right? From last couple of years, you can see BTech in AI, etc. Similar to that, they have started BTech in, otherwise earlier it's only EC, electronics, etc. But they started branch called computer science. Then they offered, they told any scholars can convert their branch from civil to computer science, etc. He converted his he converted from a civil engineer to computer science engineer, and his PhD 55 years back, actually in around 90 and late 60s. So his PhD is on speech recognition. Okay, speech 50-60 years back, his their imagination, first imagination is they want to start speech recognition, artificial intelligence, speech recognition. That time they hardly worked on word recognition, etc. Or digit recognition, etc. Because they thought, they got bored to type, dial the phone numbers, etc. So they thought, let us build a recognizer. I will tell the phone number and the call should go. That's where this speech recognition started. Come to up to the Alexa stage. When I met him 5 years back, he was very happy, to see Alexa, because it is there. This is exactly the word he used is, oh, I am fortunate that I'm alive still now to see Alexa, because it is their brainchild. Means a lot of people have owned it and done a lot of work, etc., etc. That's a different matter, but because they've seen a product out of it. It's not in the lab anymore. It came as a product actually. So what made this as a product? Because of the deep learning performance. The performance is, for as long as the performance is in the red line, It's difficult to develop a product out of it. But if it is in the blue line, which is crossed the required bar, maybe 85, 90%, no system will be 100%. Okay, no system will be perfect. So it's fine. If you cross the barrier like 80, 90%, then you can make a product out of it. That's what's happening actually. Why there is a lot of boom for AI in the industry? Because we can develop AI-based products. Okay. So now the question is, why this red line is saturating? Why the other classical machine learning algorithms are saturating? Why neural networks is improving actually? So the reason behind is the number of statistical parameters to optimize in, after all, this is take the data and take some features or take some information from data and try to do some statistics, right? So in the classical machine learning models, the number of variables available to optimize are limited. You take any model like support vector machine, hidden Markov model, or Gaussian mixture model, random forest, Navi base, any algorithm you take, classical machine learning algorithm, they have fixed number of parameters to fine tune. Okay, there are fixed number of parameters to fine tune. But on the other hand, neural networks, why it is called deep neural networks, or why deep has come? If you have more data, you take more number of layers or more number of neurons and fine tune your data, and suddenly it is giving the high performance. That's why it is called deep learning. Why? Because you can use a deeper network actually, which can absorb your data and give the better performances. The only disadvantage of this deep learning is it requires huge computation power. Along with that, the disadvantage is that we are getting this performance, but we don't know how it is coming. We know the amount of data is more, we are somehow fine-tuning the model, and suddenly it is giving better performance. But if you want to explain why my neural network is working better, explainability is an issue. Because we have 2 lakhs plus parameters or something to give us a good result. So how can we explain this 2 lakhs parameters? How the 2 lakh parameters are contributing to the decision making is a very difficult task. That explainability is possible in old classical machine learning models, but it is extremely difficult in deep learning. But as long as you get a higher performance and the application is not critical. For example, application is critical, etc., then deep learning may not get approvals because it has issue of explainability. If keep explainability aside, this deep learning performance are much better than classical machine learning. That's why the products are coming out. Okay, that is one. And other advantage, what I said here, some of the applications of deep learning you can read out here: speech recognition, image classification, natural language processing, chat bots, personal assistants, all whatever you have AI application, you can put everything here. Now the question is, how come one approach or one neural network approach can solve different problems? Because you see here, this problem is different. This is a simple classification problem. And this problem is different. This is a sequence to sequence mapping problem. They are still under classification. Sometimes you may need regression or a curve fitting or a time series forecasting. There are different AI problems. So all problems are not same. Here also, image classification, chatbot, anomaly detection, drug discovery. These are different problems, different classification. Not only area, actually the problem itself is different. Not all are classification problems. Some are prediction problems, etc. So how one model can solve all these problems? Traditionally, we have one algorithm for each of the problem. For example, image classification, support vector machine is very famous. For example, prediction or time series forecasting, ARIMA kind of models are very famous. Similarly, for in speech, Gaussian mixture models are very famous. Now, this neural networks has come and said, all the problems are fine. I can solve all the problems. How can one model solve all the problems? Because all problems are not same. So that is happening because another beauty of neural network is it has the concept of architecture. Okay, it has the concept of architecture. So what it means? So I'll come up with the different architectures. Architecture is nothing but how your neurons are connected to each other. How your neurons are connected to each other. Neurons are in my hand. I'll try cleverly, combine them in particular way so that it can solve. One network may not solve all the problems, but I will come up with the different architectures which solve my problems. Okay, that is the beauty. So last 10 years, if you see the AI growth, it's all about coming up with the new architectures in neural networks. So for example, one architecture, let us CNN, convolutional neural network. Okay. Or let us say DNN with attention, or LSTM, or few architectures, somebody proves that this architecture is working very well on a particular classification problem, then all other people are trying in a similar problems actually. Okay. So it's all revolving around one term called neural network architecture. These two are the beauties actually. The actual beauties of neural networks is a lot of parameters to fine tune, and other one is architecture. So architecture, you should not use the architecture blindly. You should know which architecture I should use for my problem and try to apply that. Okay. So, if anybody knows, along with the classical machine learning, if anybody knows at least 4 or 5 architectures of neural networks and able to build the model from end to end properly, your job is ready actually right now. Okay. That is the need for it. Okay. So what I mean by architecture, you might have heard this term, right? Convolutional neural networks, CNN, LSTM, long-term short-term memory, recurrent neural networks, graphical neural networks, teacher-student neural networks, different architectures have come. Okay. Actually, the beauty of neural networks is that earlier, after 20-25 years of history of hidden Markov model, nobody thought, hidden Markov model will be ruled out and it's all about neural networks. It is because neural networks actually are the discriminative models. Okay. I'll come back on that if time permits. What is a discriminative model? But it's a particular kind of discrimination model. They thought, this sequence to sequence mapping is not possible using neural network because it needs memory, which is impossible for neural networks, is what people thought. But the moment LSTM, long-term short-term memory architecture has come, that is LSTM is a part of RNN actually, recurrent neural networks. The moment the recurrent neural networks have come, they have this memory somehow, and they are able to solve the sequence to sequence mapping problem. So what happened now is that whatever may be your problem, one or other architecture of your neural network will suit and solve your problem. Now, another question comes is that, what if I don't have an amount of data? Yeah, what you said is fine. You have a more amount of data. Yeah, neural networks is working better, but I don't. It's not that you don't have data or you don't have computation power. Across the world, particular problem don't have a data, then it's a real problem actually. So how to create the data, etc. Unless it is some kind of a typical medical issue or etc. But most of the cases, data creation is a process, but data creation is doable actually. Okay. So even then, without that also, there is a solution in that, last 5-10 years. Another aspects of neural networks, what people are exploring is the transfer learning. Okay. One is architecture. Other is a model, different parameters, what we have in neural networks. These are all the different parameters actually. You can see on the slide, number of layers, neurons, all that, activation function. Some people can come up with activation functions. Earlier, it's all about tan, hyperbola, etc. Now ReLU, etc. has come, which is also a revolutionary activation function. And loss function, you can come up with your own loss function, etc. So a lot of papers are there, whether at the architecture level or come up with the new parameters to train your model. Or another one is the transfer learning actually. So what is mean by transfer learning, right? So for example, I'm trying to classify some 100 images which I have. Let us say I have my data, I have only 1,000 or 100 images only I have. With that, I can't build a big network, right? So, but what we can do transfer learning. What is mean by transfer learning? You take a neural network which is trained with a huge data, maybe some 10 lakh images, etc., which you can't train anyway. But let us say Google kind of people have trained and given a model. Then you can take that model and fine tune with your less data, and they started suddenly working better. Okay, that is called transfer learning. Okay, pre-trained models, you might have heard about YOLO, Inception, ResNet, etc. They are old, ResNet, etc. old, but YOLO is the one of the a lot of versions are coming. I think now YOLO V8 or something is happening, V7, V6. So these are all pre-trained models which fine-tuned with huge data detection, COVID detection from chest X-ray using this kind of pre-trained models, etc. So, for example, COVID, you may not have a lot of images available right now. So you can take less amount of data and take the already pre-trained model and try to adapt that model with your data, and they are suddenly started working better actually. So so all this, is the how AI is going on actually. Yeah. On a lighter note, the people at the classical machine learning are the signal processing people. Counterpart to deep learning, this blue line is increasing. Yes, deep learning is improving the performance, and they are. I didn't draw, but they are drawing one more line. Just opposite to this one. Inverse of this one, like this. That's where our human understanding is going. Actually, we have, if you have less data, etc., we have a good understanding of the problem. Slowly we are getting the better performance, but we don't know what is happening inside the system actually. It become a clerical job, like take data and take data and take data and fine tune the model, etc. Okay, so it's become a a kind of a clerical job than a more intellectual job is what people are feeling. But AI got a lot of boom because industry took over actually, because the moment it has the required performance, the industry took over actually. Okay, so yeah. So this is how the that's why why I think some of you may know already, but somebody may not know. That's why this AI boom, it's not came suddenly, because it's the reasons behind is the neural network actually. Because of the high performance of neural networks, the industry has running after that. You might have heard about ChatGPT, etc., right? That is also a neural network architecture which is trained with huge amount of text data, right? Yeah, going forward, I can explain how speech is applied. For example, for speech recognition, speaker recognition, this Gaussian mixture model is very famous actually. So let us say I will take some data from every speaker, okay, and I will try to fit into Gaussians actually. The idea is this one actually. So if I fit the data into Gaussian, so different, let us say blue is one speaker, red is another speaker, or blue is one language, or red is another language. So what is the assumption here is that if I extract some features from my particular class data and fit them into Gaussian mixture model actually, not one Gaussian, multiple Gaussians, then the mean and variance of the different data will be different is the main assumption actually. This Gaussian mixture model is very famous in speech recognition, sorry, not speech, speaker recognition, language recognition, or emotion recognition, etc. In 20 years back actually, people started with Gaussian mixture model. It works well. But if you have more number of classes, we need more data to find, because we need to use more number of Gaussians. If I want to use more Gaussians, I need more data to fine tune the model, because if I have less data, I can't fit them into multiple Gaussians. For example, I want to fit the data into 1000 Gaussians. 3 Gaussians is okay, but 1000 Gaussians means I need more data, right? Then what people thought is that, can we, just like your pre-trained models, what I mentioned, traditionally on GMM itself in early 2000s, people have applied something called universal background model. What is that? For example, I want to develop a I want to develop a speech recognition, speaker recognition system for EC department. What I will do, I will go to CSE department and take some 100 speakers data, okay, and 100 speakers data, and build the one Gaussian mixture model, combine all of them and build a one Gaussian mixture model. That one I am calling it as UBM, universal background model. That model I will try to adapt it to the small amount of data which I take from every speaker from EC department, let us say. So basically, to reduce the if I want to use 1000 Gaussians, I will build the 1000 Gaussian background model, and I will use small amount of data from each speaker, maybe some 1 minute of data or maybe 30 seconds of data, to fine tune that model, and that is working better actually. So it's a journey of 5 years. After that, again, they thought, this UBM is okay, but all these 1000 questions are contributing to my task, or they may be not contributing. Let us apply joint factor analysis and reduce that 1000 into maybe 200. Okay, that is called I vector, intermediate vector actually. So that is another 4 or 5 years of journey. This GMM, UBM, I vector has a lot of journey, 10 to 15 years of journey. Then suddenly this, okay, this is PSR. I'll come back on this, but they suddenly then neural network has come. Okay, neural network has come and say that I work better than GMM. So people are not willing to move to neural networks by leaving GMM, but the moment it is giving better performances, people moved from this GMM, UBM, and I vector to deep neural networks. Fortunately or unfortunately, the current state of the art is the deep neural network based, or with attention or without attention, etc. Similarly, another problem called speech recognition, right? So for speech recognition also, people traditionally thought, hidden Markov model. Okay, hidden Markov model. Each of these explanation will take a day time to, at least some 6-7 hours of explanation is required to understand each of these architectures actually. That's why I'm not going to the more details of it, but I'm giving an overall picture actually. So traditionally GMM, HMM, which has more than 15 years of existence. After that, this GMM is replaced with DNN. Basically, this is HMM only, but in HMM, to get the symbol probability, you can use GMM. Then when neural networks are getting popular, then people thought, okay, they didn't thought that HMM will be replaced. They replaced GMM with DNN. That is giving like slightly better result. But the moment this RNN has come, this LSTM and RNN's recurrent neural networks has come, that has replaced the entire HMM framework, which is more than history of 20-25 years actually. So that is all gone. Now it's all about end-to-end networks, RNN, CTC, encoder, decoder, now wave to wake, etc. has come. So this actually what I'm trying to say, two important points. I can go deep into each of these architectures, etc., but I think we don't have enough time and etc. But what I'm trying to say, a couple of important, interesting points which I want to mention to you is that from last 5 to 10 years, field has changed drastically. Okay, fields has changed drastically because of neural networks. And second important problem is most of the traditional problems are dead. I intentionally mentioning, right, GMM, HMM has a history of 10-15 years, DNN, HMM has a history of some few years, etc. Now it's all replaced. So what I'm trying to say is that earlier any problem used to have long-term existence. Maybe if it's speech recognition, maybe 50-60 years. Other problems also may have a history of maybe 20 years, 30 years like that. They still people can contribute something to improve. But suddenly neural network came and say it trashed all the other algorithms and giving a better performance at that too of more than 90. Or for example, some problem. Please understand. Right, let's say for next 5 to 10 minutes, I will talk a little bit philosophically through my views actually. So any problem which crosses 1 minute, you put it down. So any problem, any problem, which crosses, let us say 90% or something, then it's no more a research problem. It is it's all about industry. When they can take up based on the need, etc., they will take up and make a product out of it. So, we have, India, who is the largest population country in the world? We cross China also, right? India. But what is the issue with our education system, etc., is that our education system is strong, no doubt about that, but anyway, slowly it is getting weakened. And especially in the research side, we are not at the forefront actually, because we have a lot of energy, but we don't have confidence, and we are not putting in the right direction actually. So we are we are always especially at the research side, we are always trying to find the shortcuts and some problem and do something and get away. That's that thing we should come out of it. But only that one of the aspects we should mention, we should question ourselves is that before putting an effort on any problem, try to understand that is that problem needs your attention or not, it needs anybody's work or not. Okay, So if some some problems, yeah, one aspect you have to understand is compared to earlier, now in one way research doing is easy, one way it is doing difficult also, both, because we have a lot of tools to do it easily. And second thing is the problems, the traditional problems are gone actually. So there is no point if somebody is working, sir, I saw the literature, I got the performance are around 95, 96. I made it to 96.2 using my algorithm. What a big trash. That is not research actually. Why we need to put our lot of effort and try the entire thesis of 4-5 years of effort and making that 95 to 95.2 or 3? What is the use? Or even let's say 95 to 96. Even human will do 4-5% of errors. Nobody is perfect. So if any system crosses are 90-92% or something, 90%, don't take that as a research problem. And fortunately or unfortunately, 90 to 95% of the traditional problems, which if you see in the literature, are in this stage. So what in one point what I want to mention is come out of the conventional problems. Conventional problems need no more research attention. They are almost coming like a products. Okay, so don't spend your time on that. Yes, you have to come out of your comfort zone and try to start a slightly new problem in your own domain. It may be image processing, it may be speech, or it may be text, or it may be any area, right? But make sure that before putting an effort, before giving your let's say you are already doctorate, before giving your problem to your student, make sure that it's not that I done that problem, I want my student to extend or somebody. No. You see the state of the art result, and if it crosses particular stage, it's extremely difficult for us to contribute. One of the issue with India is also we have lack of resources and some computation power. All that is also there. That I agree. But apart from that, we try to see whether the problem needs our attention or not. That is a basic question we should put. Otherwise, try to start a new problem or try to start a problem which is within our local problem. For example, in speech, you will, instead of me working for English or something, let us try to see what problems in Indian context or what problems in my region context. So every region has a lot of dialects, code mixing, and a lot of issues are there. Or let us say that is one aspect. Other aspect is, let us say, medical speech, which is slowly getting attention nowadays. Okay, so can I put my energy there? So we have to try to find a problem which of course, which also should be important to address. It's not that I will cook up some problem and address. That is also not good way. So, but we have to spend enough thought on what may be the good problem, because traditional problems are dead, and also some of the problems what we are thinking is a problem is getting dead after a few months, not even years. Earlier problems used to stay for a year or two, but now because of the algorithm development, because of the industry running after, because of the more manpower on the problems, most of the AI problems are getting solved in few months. After ChatGPT, all of you know the ChatGPT, right? Now it is extremely difficult to publish some of the NLP papers, because the algorithms what we develop, we may not beat ChatGPT. Gone. Why you have to work on that? People say, I will use ChatGPT. And you developed a neural LSTM and some embedding, some algorithm you developed in NLP and got some 90% result or 80% some result, and ChatGPT comes and says, I am at 95. Or the chapter closed. So we have to be very cautious, especially if you want to work in AI. You have to be very cautious while choosing a problem, okay? Because some of the problems are getting solved in few months, okay? So we have to be very cautious. That is one part. And having said that, there are so many problems to be addressed. There are so much work to be done. There is no doubt about that. It's all about how we choose them. That's all. Okay. And yeah. I'll skip this one. I'll play a few demos, and I'll also tell what works I'm doing currently in my lab right now. Okay, is that okay? So before that, can I take some questions?
Participants, if you have any questions, you can post it in chat box or you can raise your hands.
Greetings to one and all. We are from Speech Lab, IIIT.
Can you get the audio of this video? Are you able to get?
Today, we are going to show you a demonstration of a complete end-to-end pipeline of speech-to-speech machine translation for broadcast speeches. The main motto of this project is to convert a Mann Ki Baat audio into other language audio. So, let us consider an audio file which is taken from one of the sessions of Mann Ki Baat. The audio file which we have taken is of 1 minute duration. So let's try to upload it. So in this pipeline, there are three main components. Those are ASR, machine translation, and speech synthesis. The main job of an ASR is to convert a given audio into corresponding text. Machine translation. In machine translation, it takes text as an input and tries to translate to destination language. Whereas in speech synthesis, it takes text as an input and tries to synthesize to corresponding speech. In this platform, we have integrated ASR's API from Google, Microsoft, and CDAC. For the sake of demo, we would be selecting CDAC API. In translation, we have integrated Google's Translation API and Microsoft Translation API. In TTS, we have integrated Google's TTS API, IIT Madras TTS API, and Microsoft TTS API. So in this demo, we would be selecting IIT Madras. So the source language here is Hindi, and I would like to convert Hindi audio into Telugu audio. So let's start converting. So this platform which we have developed is also robust enough to convert 2 hours audio. But the latency involved in it is around 1 hour roughly. So we have uploaded a 1 minute audio duration file. So it would take nearly 30 seconds to complete the pipeline. So the ASR output is towards left and translated output is towards right. This is the ASR output text. This is the translated text. Let's hear the TTS output.
ప్రియమైన నా దేశ ప్రజలరే, ఇది నా సంతోషం కోసం మన్ కీ బాత్ నా ద్వారా కోహిమా నుంచి కాశ్మీర్ వరకు కన్యాకుమారి వరకు దేశవ్యాప్తంగా పురులందరూ ఒక్కసారి పలకరించే అవకాశం వచ్చింది. హలో, మీరంతా మన దేశపు వస్తుత వైవిధ్యం. ఈ విషయాన్ని గుర్తుంచుకోండి. తగిలపడును ప్రతి భారతీయుడు అహంకారంతో నిండిపోతుంది చేసి ఈ వైవిధ్యాన్ని అనుభవించే అవకాశం ఎప్పుడూ ఒకేలా ఉంటుంది. ఉత్తర విక్టరీ అమృతానందంతో ఒక పద్ధతిలో ఆవేదన పుష్పం ఉంది. కొద్ది రోజుల క్రితం నేను ఢిల్లీ వచ్చాను. చిన్న స్థలంలో మన దేశపు స్వరూపం, సంప్రదాయాలు, ఫుడ్ అండ్ డ్రింక్, భావోద్వేగాల వైవిధ్యాలు కనిపించాయి.
So now let's upload the same audio file. And select Microsoft ASR, translator Microsoft, and speech synthesis also Microsoft. Source language as it is Hindi. And I would like to convert Hindi audio to English audio. Let's start converting. In this pipeline, the first block is ASR. The ASR tries to convert speech to text, right? And the next block is machine translation. The output of an ASR is fed to machine translation so that it can translate the ASR output text to destination language. Here, the destination language is in English. And the translated output is fed to TTS API. So, the output of translation tries to synthesize and generate TTS outputs here. So roughly it would take 30 seconds as we have given 1 minute audio file. Yes. This is the ASR output, which is generated from Microsoft's API, translation from Microsoft, and synthesis is also from Microsoft. Let's hear the synthesized output.
My dear countrymen, these are my good fortune. Me through that man ki baat. From Kutch to Kohima, Kashmir to Kanyakumari, all citizens across the country. Then there is a chance to greet once. Hello you all, the vastness and diversity of our country. To remember this, to go down to it. Every Indian fills with pride, and there is always an opportunity to experience this diversity, to be overwhelmed, to fill with joy. In a way, there is a flower of inspiration. A few days ago, I have been in Delhi, in Hunar Haat, in a small place, the vastness of our country, culture, traditions, catering, and appeared in the diversity of emotion.
So you might have seen this demo, right? So yeah, so some kind of automation. This is all automatic generated output, which is fine. But if it is a kind of education domain, etc., which needs 100% correction, so we need some, here some errors may come, here errors may come, so we have to correct it manually before synthesizing actually. Okay. So this problem is not a simple problem. It is a man ki baat. For example, man ki baat is a very well articulated speech, curated speech. But for example, you are giving a live lecture, there is a lot of disfluencies. And that means I'll say okay, or I will do some prolongation because I'm thinking and speaking. Sometimes I will correct the sentence, and also speaker. I don't want that some female speak in English what Prime Minister Modi has spoken. I want to listen as if he is speaking, all these things are to be addressed. So we are focusing on these aspects actually. Okay. And also text to speech should have a natural feel. It should not be like a railway announcement, etc., like a monotonous way. It should have some, source speech characteristics actually, So it's a long way to go in this problem. So this is one problem which
We would like to thank
which we are working actually. And apart from that, I am also working on, okay, sorry. So this is, you can also access this. We have something called asr.triple-it.ac.in. Okay, this is what we developed in our lab. This is, you can click on this text with voice option. Okay. Down. I think our people are updating this one. Otherwise, it works. We are also working on speech recognition on Indian languages, speech to text conversion. We kept our models online for online testing actually in this ASR.IIIT. I think it is getting updated, so I'm not getting a link here. Okay. So in between, there are some questions, it seems. What are those? Could you please send me the class recording video? Okay. Coming to English machine learning data set available in online. Okay, I think some of the people are asking what are the AI tools required or what are the data sets. Actually, there is something called Bhashini where people want to keep most of the data sets in that collected from various places. So I think there is a good amount of machine translation data, text to speech, ASR data, or AI for Bharat is another or egg step. These are the if you want Bhashini. Okay, this is a Bhashini platform. You can check some of the data maybe there here or egg step or something. Yeah, egg step. These people also have some resources. You can see what resources they have. Okay, and also AI for Bharat. Okay, so these people also doing, in that resources, you can see the data sets. Okay, some of the data sets they have released actually. Okay, so I think some of these may be useful for your work. Put this question on in the internet, you'll get a lot of answers actually. So for AI, for that matter, any research or any question, you can, or you put the same question to ChatGPT, it will also give the answer. But anyway, of course, experience based on my experience, actually, this Python-based frameworks are there, like Python and Anaconda or Mini Anaconda and TensorFlow. These are all free packages which you can use to build the AI model. And also, I can type here Python Mini Anaconda. I recommend all of you to, if you are a researcher, please work in Linux because most of these tools are freely available. TensorFlow. TensorFlow is for neural networks building, etc. Okay. So for speech recognition, there are frameworks called Kaldi, Speech Brain, etc. These are also free tools, but it requires some amount of effort to understand how to install them and use it. Any other? Yeah, there are a few other customized packages are also coming on AI, but these are freely available where you can explore different building different AI based applications. Hope it answered your question, Mr. Jagan Mohan Rao.
Any more questions, participants? Okay, then we can proceed for the vote of thanks. Dr.
1 minute.
Prathaman, yeah.
1 minute, madam. This has come. These are all recognition systems, which most of these are using existing data. But this one is what we collected. It's a 1.2 crores project. We collected 2,000 hours of Telugu data. Telugu audience may appreciate this one. నేను తెలుగులో మాట్లాడుతున్నాను. ఇక్కడ ఏం జరుగుతుందో చెప్తున్నాను. వీళ్ళందరికీ అర్థమైందని ఆశిస్తున్నాను. నేను తెలుగులో మాట్లాడుతున్నాను. ఇక్కడ ఏం జరుగుతుందో చెప్తున్నాను. వీళ్ళందరికీ అర్థమైందని ఆశిస్తున్నాను. Except one error here, most of the text has come properly actually. Okay, this is what we developed in our lab actually, and We are also working on this multilingual. Actually, right now we didn't host a demo, but we can speak in 6 languages. One recognition system itself will recognize actually. This is the one with small amount of data of Tamil, Telugu, Gujarati. Podumakkal, Mahati Anusara, Teliyadu. I used Tamil, Gujarati, and Telugu words, but yeah, I think some errors are there. But the idea is that one recognizer will recognize different languages and display, because the idea is India is a multilingual society and code switching is quite common. So how to handle that is one direction which a couple of PhDs have guided. It's one of the outcome from that actually. Okay. Yeah. Okay, that's it from my side. If you have any questions, I can handle. Otherwise, you can go ahead.
Thank you, sir. It was a very nice session, and I think it's a very interesting tool that you have developed for multilingual languages, because India is having a multi-languages people here. So it will be really very helpful for the community in future. Now I request Dr. Pradyuman Ranjan Ghosh, sir, to propose the vote of thanks.
Thank you, ma'am. Good afternoon, everyone. Good afternoon, Dr. Anil. It has been an honor to be a part of this wonderful event. On behalf of Bharat Institute of Engineering and Technology, Hyderabad, I would like to extend our heartfelt gratitude to the esteemed resource person, Dr. Anil Bhupala, who is an associate professor in EC department at IIT Hyderabad. IIIT Hyderabad, for enlightening us with the knowledgeable discussion on artificial intelligence and machine learning in speech processing application. Especially his talk on the boom of deep learning algorithm over other conventional machine learning algorithms, and also the demonstration which he gave at the end was also very helpful. We are also thankful to our honorable chairman, sir, for providing us with the infrastructure and facilities, as well as giving us continuous encouragement for holding this fruitful session. We also extend our thanks to our fellow coordinators, Dr. Papia Datta, who is the chairman of IIC at BIT, Dr. Anirban Ganguly, and Dr. Satyavrata Singha, because without their ideas, these programs would not have been possible. And sincere thanks to all the participants who made this event a memorable one. We look forward to another successful session with all of you just after this. Till then, have your lunch. And thank you, Dr. Anil, once again for this wonderful talk.
Thank you. Thank you everyone for inviting
Thank
me.
you, sir. Thank you so much for giving a precious time. Participants will meet after the lunch at 1:30 p.m. We'll start the session. Next session will be by Dr. Shuman Dev from NIT Agartala. So all of you join in advance around 1:30 p.m. and 2 p.m. directly we are going to start the session. So thank you all.
Thank you.